Hello, welcome to Woodworking for Miniaturists. My name is David Knight, and today I'm going to yammer on at you about tools. This will probably take a couple sessions, and it will only be a partial treatment of the subject. We'll deal with the use of these tools to a greater extent in other episodes when we're doing specific procedures. So let's start with the pencil. There are many uses for a good pencil. Marking where to saw wood, where to cut it with a saw, is not one of them. A pencil mark is not sufficiently precise for miniature work because it has a visible width. Do you cut just to the left of the line, just to the right down the middle, just to one side of the middle but still on the line? That pencil mark does not tell you. Mark your cuts with a light knife cut, because a cut in the surface of a piece of wood comes as close as possible to having zero width. And you can line your saw up on one side of that line and know that's precisely where your saw is supposed to be. And in combination with always cutting on the waste side of your mark, it allows for big improvements in precision. I'll go into more depth about why this matters in the section on cutting procedures. Most how-to books depict the marking of saw cuts with a pencil. One author recommends a 0.5 millimeter mechanical pencil for precision. This would have the advantage of being consistently inaccurate, at least as a cutting guide. Even a 0.5 millimeter is too wide of a mark. A regular pencil can be sharpened to be more precise than 0.5 millimeter, but only when it's first sharpened, and of course that sharpening does not survive its first use. Here's the essential truth. Even at its sharpest, a pencil mark is too wide to produce a precise cut. Awareness of this truth comes directly from my full-scale woodworking experience. Tight dovetail or mortise and tenon joints require the marking precision provided by knife cuts as the cutting mark. If this is true in full-scale woodworking, it is even more so on a reduced scale. You can use them to draw curved patterns that you're going to cut with a jigsaw. Those are not part of matching joints, and so the precision is less critical there. Pencils are available in several hardness grades. The standard soft pencil is the well-known number 2. Pencils used in mechanical drawing are usually the harder number 4 pencils, and they leave a fainter line, a line that's easier to get rid of and erase. Art stores have pencils with white lead, and those are useful for marking dark woods and dark-colored card. As I mentioned, keep a good pencil sharpener in your kit. Use it often. But remember that pencil sharpness doesn't mean that you can mark your cuts with a pencil. Learn to use your knife. Our next topic, knives. Beyond a doubt, a knife is the most used, most important tool in your kit. I use several knives, but 99% of the time I use an X-Acto-style knife, generically called a craft knife, with a pointed triangular blade designated the number 11. This knife can cross-cut, rip, cut straight lines and curved, shave off thin layers, carve, chip carve, and whittle. It cuts wood, paper, cardboard, flooring, wallpaper, rubber, plastic, leather, vinyl, fabric, hemp, bamboo, and coconut husk fiber, and any part of your body that gets in the way. By the way, keep a supply of Band-Aids handy in your kit. And a knife makes a mark to guide your saw cut that is finer and thus more precise than any pencil can possibly do. I have found that X-Acto makes the best blades. They're less prone to snapping off at the tip and slower to dull or rust. On the other hand, the standard metal X-Acto handle is uncomfortable and gradually wears out. After a while, it fails to clamp the blade tightly. I use a handle that is larger, made of softer material, and ergonomically shaped to fit my fingers. It has a different kind of blade lock than most craft knives, and it seems to hold the blade rigidly. Time will tell if that clamp wears out. This handle is made by the Swedish company Fiskars. They make a lot of sewing tools, including excellent scissors. They also make plows. In my farming days, I owned a 16-inch 3-bottom Fiskars plow on a 3-point hitch. Weird. Plows and scissors. I guess the common denominator between plows and cutlery is quality Swedish steel. It was a damn good plow. On the other hand, the blades that came with the Fiskars knife did not seem as sharp and durable as the X-Acto item. Mix and match as appropriate is what I say. The picture shows a Fiskars handle with a triangular number 11 X-Acto blade along with its protective cover, and a metal X-Acto handle with a chisel blade and its condom. The X-Acto system allows a handle to hold a range of tools. Other available blades include curved knife-edged blades and tiny little saw blades. Other knives exist and should be considered. I have a pair of knives designed specifically for carving and chip carving. The handles are comfortable and the blades are substantial, certainly sturdier than an X-Acto blade. They can be resharpened over and over, and if you learn how to sharpen your tools, you can form an edge as good or better than X-Acto can. I use an X-Acto knife and replaceable blades for the sake of convenience. Sharpening takes more time than just popping in a new blade. As I was writing this, the mailman delivered a package of 100 number 11 X-Acto blades, which came from Office Supply and cost $36. I'm so excited. I restrained myself, actually, and did not order the package of 1,000. A quilting circular cutter probably does the best job of cutting fabric in a straight line. It's not of much use for other materials, wood or paper. You will be working with fabric if you make curtains, bedding, miniature quilts, or upholstered furniture, or dollhouse doll clothing. An alternative tool for fabric would be scissors, of course, which are also useful for many other materials. The cutting wheel on these rotary cutters can be replaced if it gets dull. A discussion of knives would be incomplete without mentioning what are called self-healing cutting pads. These also come to us from the world of fabric and quilting, and were made especially to be used with circular cutters. They hold up fairly well to knife blades and saws as well, but not as well as they stand up to circular cutters. I have to replace my cutting pad once a year or so. Without this protective pad, I would eventually cut a hole through my bench. These pads have a grid in inches printed on them, which is useful for checking measurements and square. There are also angled lines at 45, 30, and 60 degrees, which can be handy depending on what you're working on. I also have a small cutting pad that I take on vacation. The one pictured here is 17 inches by 24 inches, and it covers most of my workbench. Rulers. Here's the thing. Rulers have two purposes, and it turns out that a ruler which is good for one purpose is not so good for the other. First, you need rulers to draw or cut a straight line. You also need rulers to measure things. Sometimes a ruler is not the best way to measure things. There are other ways of measuring things, as we will learn, but it is the typical way that we make our measurements. When you were in grade school, you had a plastic or wooden ruler, and you used it for both purposes, to measure and to draw straight lines. Those rulers were not very accurate, and because of their soft material and thin edges, they could be easily damaged by cutting tools. Some miniaturist how-to authors recommend accurately marked steel rulers with a layer of cork on the bottom. The purpose of the cork is to help keep the ruler in place, keep it from slipping out of place halfway through drawing a line or cutting a line. A ruler that holds still while you are cutting or marking is a good thing. But I found that the cork lifted the edge of the ruler up off the surface just a little bit. It felt like that would reduce the accuracy of my cut or line. There are other ways to hold your ruler still, as we'll find out. Sometimes the technology from one craft turns out to be an excellent addition to a different craft. When this happens, it represents the kind of carryover that I've been promoting throughout these videos. When I was doing a lot of quilting, I learned about quilting rulers, which for my money are the best tool for drawing or cutting a straight line, not only on fabric but on paper, card, or wood. These rulers are available in quilt shops and come in a variety of sizes. They are made of clear hard plastic and are 1/8 of an inch thick at the edge. The marks are printed on the bottom. You can see them through the top of the ruler, but the marks themselves come right down to the wood where you want to put your measurement mark. They have a 1-inch grid divided into eighths and in some cases 16ths. I use one that is 1 3/4 inches wide and 6.5 inches long. I use that for shorter cuts and marks. And I have another one that's 18 inches long and 3 inches wide for longer cuts. So why do I think these rulers are so great? The key is their thickness. A ruler like the one you had in 5th grade that comes down to a thin edge on the wood allows a knife to easily ride up onto the ruler, making an inaccurate cut or mark and slicing up the ruler. An edge that is 1/8 of an inch thick makes this much less likely. It's easy to keep your pencil and to keep your knife up against that edge and not have it skip up onto the ruler. I've been using my 2 favorite quilting rulers for years now, and I have yet to see any sign of wear. That is something that you might be concerned about, that running a steel knife along a ruler is going to wear it out, but I'm not seeing that wear yet. And if I ever do, these are not expensive things to replace. Quilting rulers are marked with a precision that is appropriate for quilt fabric. And for some measurement purposes, they are perfectly adequate. As you will see, I use my quilt ruler to cut long strips of wood, like floorboards or clapboards. Their markings and their width allow them to be used as a quick check on squareness. They are often marked with 45-degree and 60-degree angles, which can be useful in marking, cutting, and assembly miter joints. Their thickness allows them to be used to apply pressure to a glued joint, a technique I'll discuss in the section on gluing. Some quilting rulers, my 6.5-inch long quilting ruler, has rough patches on the bottom, which give them a grip on the wood or paper or fabric. They're very effective, and this helps to prevent slippage in the middle of a cut, and it works very well. My large quilter's ruler does not have these rough patches, so I applied some aftermarket soft rubber patches sold specifically to keep the ruler from slipping. These are called True Cut True Grips, and they're available through quilting sources. Quilting rulers work best to guide cuts along the grain of the wood, rip cuts. You should probably use a machinist square to guide cross cuts. In another section, I'll show you how to use these rulers to cut multiple strips of identical widths. So to summarize, clear plastic quilting rulers are best for rip cutting or marking straight lines with a pencil, a knife, or a circular cutter. And they're useful for rough measurement and checking squareness, but they are not precise enough for some other miniature work. Brand names of quilting rulers include Creative Grids and Omnigrid. Any quilting shop will carry them. Internet sites include Sewing Parts Online and Connecting Threads. I found a 1.5 by 6.5 quilt ruler on sale on the internet for $9.99 and probably $12 shipping, and a 3.5 by 18 for $25.99. You'll see a lot of large square versions in quilt shops, and those are useful for quilting purposes, but for woodworking what you want are quilting rulers that are long and narrow. They will do the jobs that you need to do better than the square ones. So let's talk about rulers that are specifically for measurement and other tools that are also used for taking measurements. Using a ruler to make measurements is a different job from making straight lines and straight cuts, so it's best done with different equipment. Let's begin with the job of marking out panels of plywood that you might use for the walls, the floors, and roofs of dollhouses. For longer measurements, what you want is a tape measure. Get a good one made by Stanley or Lufkin. You won't need a big carpenter's version. A 6-foot tape measure will be sufficient for making miniatures and dollhouses. Pick one that has a built-in lock that will hold the tape in an extended position. You will notice that there's a little silver hook loosely riveted to the end of your tape measure. You might think that the loose connection would make your measurement inaccurate. You would be wrong. It's probably not the first time. This end hook is precisely engineered so that when extended, it gives an accurate measurement to the outside of a board, and when contracted, it gives an accurate measurement for some kind of inside space, say to the inside of a drawer or cabinet carcass. This shift from the outside measurement position to the inside measurement position takes place automatically when you hook it on an edge or push it against an interior panel. You will also notice that on the base of the tape measure body are markings such as +2 inches. This indicates the length of the tape measure case, the amount that should be added to the reading when measuring an inside dimension. Metal tape measures are mounted on an internal spring so that they retract automatically. Don't allow your tape measure to slam back into the case. Apply a little friction to the tape with your fingers so that it eases back in to avoid damage to that little hook, which of course would reduce accuracy. Every tape measure I have ever seen was marked out in inches and fractions of inches. So if you're working from plans with metric dimensions, you may decide you need to get really good at conversion math, or pick up a metric tape measure next time you're in Europe. For shorter measurements, the kind you'll make when building scale furniture, you will need an accurate ruler, which kind will depend on how the dimensions are written in the plans that you are using. Some plans use the actual measurements of the miniature that you're making. For example, a chest of drawers may be marked 3.5 inches wide, 3 inches high, and 1.5 inches deep. With plans like that, you can use a regular inch ruler. Find one that's accurate and marked in fine increments, 30/2 or 64ths of an inch. An architect's ruler has several scales printed on it, and one of these is always the standard inch scale. The plans published by Julie Warren, which I have used extensively and recommend highly to you, come with dimensions in millimeters and secondarily in inches, representing the actual measurements of the parts of the miniature. For example, a part may be 3 by 2.5 millimeters, and then in parentheses, along with that measurement, she would have 1/8 by 3/32 of an inch. So you're getting both of the measurements, millimeters and inches. With dimensions like that, you can stick to the standard American or imperial inch measurements if that's what you're comfortable with. However, some measurements can get quite complex in inches, such as, this is a measurement taken from Julie Warren's, one of her cutting lists, 69 by 18 millimeters, and then in parentheses, 2 23/32 by 45/64 inches. Notice that the measurements in millimeters remained quite simple, 69 by 18. When making Ms. Warren's designs, I found it much easier to stick with the metric measurements. For this, I use a small 1/2 by 6 inch metal ruler, marked accurately in inches and 64ths of an inch along one edge, and in millimeters on the other. Now believe me, I was not raised in a metric world. All my life I have used inches and feet and bushels and furlongs, and my brain does not process centa, deca, multi, or kilometers, or Celsius for that matter. But once I gave millimeters an actual try, it went quite well. There is a much smaller chance of making a mistake. You never have to convert 30 seconds into 128ths or any other fraction. Adding two lengths together or dividing a length into half or thirds is very easy and straightforward. As it is marked out on most rulers as millimeters, it is a less precise system than inches, which can be subdivided forever and are usually marked out as 16ths or 30 seconds. But it seems to be about as precise as it needs to be for our purposes. To review, some plans are written in actual miniature inches and some are written in actual miniature millimeters. But most seem to be written in full-scale inches, where a chest of drawers would be marked 40 inches high, 30 wide, and 15 deep. If we can figure out how to use plans written this way, the range of furniture we can make expands a great deal. There are many, many books and magazines of designs for full-size furniture that could be used to make miniatures. We could even take measurements from a favorite piece of furniture or a valuable antique and produce a scale model. If only we knew how, huh? Well, there is a way to do exactly that. It's called an architect scale, and it can turn full-size measurements into 1/12 scale measurements. It can also produce the 1/24 scale and the 1/48 scale, which are also standard dollhouse scales. As a matter of fact, it could do 7 other scales that you are very unlikely to ever need, like 3 30-seconds scale. In another section on the process of measuring, I will explain how to use this fanciest of rulers. But for now, let's just say you get you one. They're available where drafting supplies and art supplies are sold. You might try a college bookstore. Most of the designs that come down to us through the now defunct magazine, The Scale Cabinet Maker, and the plans in many miniature books are drawn up in full-scale inches. This is a huge storehouse of furniture ideas designed to be built as miniatures, but the dimensions given are the dimensions that piece would have if it were full size. You could spend a lot of time mathematically converting these full-scale measurements into scale measurements, and that's a process ripe for error. Learn to use an architect scale and it all becomes easy. I learned to use an architect scale from Mr. Ellis D. Willis's high school mechanical drawing class, and from drafting plans for a variety of things over the years. You may find so many scales as those that are on the architect scale confusing. I wouldn't blame you. Modelcraft sells a simple stainless steel ruler with 1/12 scale on one edge and 1/24 on the other. That might be easier to use than an architect scale. A 1-inch scale without the potential confusion of multiple overlapping scales. I might get one myself. Dial calipers are capable of very precise measurements, which read out on a dial on some models and on a screen on others. I use mine mainly to measure the thickness of my stock, but the main jaws can measure width and length within limits of its size, which is about 6 inches. It's also made to measure depths. There's a thin protrusion on the bottom end of the scale, which moves with the bottom jaw and can be used to measure the depth of a hole, for example. It also measures inside measurements using the 2 blades that face away from the main jaws. The dial turns a complete revolution in 1 inch and is divided into 64ths and into 100ths. There's 2 scales on that dial. And there are versions of this tool that run on a small watch battery and provide a digital readout accurate down to thousandths of an inch. That's a realm of accuracy normally reserved for machinists. Calipers can be found at hardware stores, building supply stores, car parts stores, and from many sources online. My main use for this tool is to check my progress when planing or sanding a sheet or board down to a specified thickness. This in-depth analysis of tools will continue starting with squares in episode 12. Join us then. In the meantime, keep the shiny side up.